Earlier in this course, we had a look at JavaScript libraries. We had a look at Axios, Lodash, jQuery as some examples. Now in this module, we'll explore JavaScript frameworks. These in the end are like bigger libraries, you could say, but we'll have a look at what exactly a framework is, how it helps you focus on what matters, and how it simplifies the project building or app building work. And we'll also see an example. Now, to be precise, I'll first of all dive into what exactly a framework is and what the difference to a library is. And we'll then have a look at React.js, which ironically is a library, but a pretty important and huge one. And if we then add a couple of other things from the React ecosystem, it actually gets more framework-ish. So we'll have a look at that and see why that matters, what's great about React, what alternatives to React are, and how that can help us in our projects. So let's start with what exactly a framework is. Now, I'll be very honest here. You can fight a religious war over this, and there are people out there to whom it's very important to differentiate what a library is and what a framework is. I'm not one of them. Still, I'll give you the common differentiation and explain why we differentiate it or why that is so important to some people. So we got JavaScript libraries and frameworks, and a JavaScript library in the end is a third-party package. Doesn't have to be, you could also write it yourself and then just share it across multiple projects, but in the end it's a package which you bring into your project that adds certain functionalities. jQuery helps us with querying the DOM, Lodash added a couple of utility functions, and Axios helps us with sending HTTP requests. So libraries typically are focused on one or a few core tasks, and they help you with that. So I already named these examples. Now, frameworks, on the other hand, also are third-party packages. They also add functionalities, but typically they add more functionalities also from different areas, and they typically also give you certain rules, a certain structure on how you should build your JavaScript-driven application. And therefore, they force you into a certain rule set, but at the same time, by doing that, they often make it easier for you to build an application and make it easier for you to focus on your core business logic and spend less time on all the nitty-gritty details. So they typically provide a complete structure for building JavaScript applications, and the big examples we got there, not the only ones, but the big examples we got are Angular, Vue.js, and React.js, though as I mentioned, React.js is kind of an edge case. It's actually a library, but a pretty big one with a bunch of different features built in, and it spawned a huge ecosystem that effectively together forms a framework, you could say. So let's have a look at these three here. We got Angular, we got React, and we got Vue.js. All these libraries here, or all these things here, are JavaScript libraries or frameworks. React is called a library, and Vue.js and Angular would be called frameworks. And as I mentioned, to some people that's really important, that help us with building JavaScript projects. Now, it's important to realize that you will still be working with JavaScript, and you can do the things with JavaScript that you learned about in this course. But these frameworks and libraries will help you do that, will allow you to focus on your business logic and spend less time on the details. For example, when you typically need to select a button and add an event listener and so on, these frameworks take such work away from you by giving you a totally different way of thinking about your project. Now, these are not the only JavaScript frameworks we have. They are particularly useful for building powerful user interfaces, but we also got other frameworks that would help us with building online shops and so on. And we also got not just frameworks for the front end, so for the code that runs in the browser, we also got frameworks that run on the server side if we use JavaScript there. For example, for Node.js, which we'll have a look at later in a separate module, there would be a framework called Express.js. But we'll focus on that later when we talk about Node.js. For now, let's stick to these client-side, browser-side frameworks here. Now, if we quickly have a look at them, then Angular, for example, introduces a new language or uses a new language, TypeScript, which actually builds up on JavaScript and which, as part of your development build process, is compiled to JavaScript. It's a bit like using next generation JavaScript with Babel, just with even more features which don't even exist in the next JavaScript generation. Now, TypeScript is a standalone project detached from Angular, but Angular heavily uses it. If you want to learn more about Angular and TypeScript, I got dedicated courses on that. Angular is extremely popular and it's a huge framework. It contains lots of features. It contains features for rendering beautiful user interfaces, for animating stuff, for validating user input. It contains everything built into the framework for sending HTTP requests so that you don't need Axios, and much, much more. Now, React is also a framework or a pretty rich library, if you want to call it like this, and it uses enhanced JavaScript syntax, as I'd like to call it here. It uses a feature which is called JSX, and this allows you to add a certain syntax to your JavaScript files, which is not supported in vanilla JavaScript, which wouldn't run like this in the browser, but which, just like TypeScript, is compiled to regular JavaScript instructions as part of your development process. And you'll see that JSX thing in action later in the React example. It in the end helps us with building rich user interfaces with the help of React, without having to write all the create element and append and remove child instructions on our own. And that's, by the way, a general idea of all these frameworks. They take away the need for us to manually add elements to the DOM and remove them and so on. And instead, all these frameworks give us a way of defining the result we want to have, defining certain conditions when that result should change, and then the frameworks will take care that changes are applied to the page the user sees when our conditions change. But again, you will see that in practice at the example of React a little bit later in this module. Now, React itself is a library, but it spawned a huge ecosystem which adds certain features around React so that even though React in its core is much leaner than Angular, it has no built-in validation, no HTTP support, even without that, we got a couple of other packages that we typically combine with React so that we can add such functionality. And just like Angular, it's extremely popular. Well, and the third big framework you have in JavaScript land is Vue.js. It uses regular JavaScript. You can use it with TypeScript, but you don't have to. For Angular, you basically have to use TypeScript. And the good thing about Vue.js is, of the free frameworks, it's the easiest to learn, I'd argue. It's all the popular, not quite as popular as the other two, but still very popular. And it, just like Angular, contains all important features. Angular ships even more than Vue.js. Angular has even more built-in features than Vue.js, but Vue.js has more built-in features than React. So unlike React, you don't need to combine it with other libraries to get everything you need to build powerful applications. Vue.js got all of that built in. Now that's the rough comparison. All three are great. I got courses on each of them, so if you want to learn more about React, want to learn more about Vue or Angular, take my dedicated courses, of course. I'd be more than happy to welcome you there. And in addition, I also attached a link to a more detailed comparison which I created in case you want to find out which one is best for you. Now with that, however, let's take a closer look at React and understand what that does for us. So what's React? It's a JavaScript library for building user interfaces in the end. Now, as I mentioned, library because technically it focuses on that user interface building part, but enriched by everything else, the ecosystem that it spawned offers. It's basically like a framework, you could say. Now, the user interface part is important though. React is all about building user interfaces that look good, but more importantly than that, that update reactively. So that you, for example, can define if this button is pressed, this data should change, and if that data changed, instead of outputting this text down there, I want to output that text. So you basically define different kind of scenarios and results, you could say, and React will then do the heavy lifting of reaching out to the DOM, adding elements, removing elements, adding CSS classes, removing CSS classes, so that you don't have to manually write all these instructions. Instead, you just manage the state, as it's called, of your application, and React will then update the UI based on what changed. This is called a declarative approach, because you declare the goal, you declare what you want to see on the screen in different scenarios, and React will then handle the way of getting there. The opposite of that would be an imperative approach, and that's basically what we did thus far in the course, where we manually had to say, now add this button, add this element, add this event listener. Now, doing that in bigger projects quickly can become cumbersome and difficult to manage, and such a declarative approach definitely has certain advantages over this, because it allows you to focus on the result and the state instead of the way of getting there. And this is less error prone and gives you more power. In React and also in Angular and Vue, you do that by defining so-called components, which are reusable UI elements. Now, not HTML elements. These are not elements the browser would understand. In the end, these are just components, basically JavaScript classes, you could say, which you define in your code, which then at runtime, when your code and React's code executes on the page, are interpreted by React, so that React then knows what to touch in the DOM and what to render where. So you don't render real HTML elements. In the end, you just use something which React then understands, and which then in the end tells React what it should render on the screen under which circumstances. So let's have a look at that. This should make it clearer. For that, attached you find a React project, and this is actually the project we worked on before. It's this project where you can find a place by entering it here or by getting your current user location, and where you can then share this place and view this place. So this is something we built before with vanilla JavaScript. I now converted it to React, and I will now have a look at it with you so that we can get a first understanding of React. Now, I did convert it off screen because this is not a React course, and you could easily create an entire course about React. Well, indeed, I do have an entire React course. Now, I don't want to bloat this course with tons of React instructions, which might not be interesting to you if you're not interested in React. Instead, I just want to show you what React or similar packages like Angular or Vue typically do, and how they change the way you think about creating such applications. If you then want to learn React or Angular or Vue, have a look at my dedicated courses. So attached you find this project, and with it downloaded, you should extract it and then navigate into this or open it in your IDE, open the terminal there, and then run npm start. npm start in the end starts also one of these scripts. The start script is a special script which you don't need to start with npm run, but where you can just type npm start. And this uses the entire setup which is provided by this project under the hood. It uses Webpack under the hood to convert the code, to bundle the code. So we got basically a setup as you saw it before, but with all the configuration and the heavy lifting managed for us behind the scenes. This is also something these frameworks or big libraries typically do for you. They give you project setups where you don't have to configure everything manually. And that, of course, ensures that you don't have to become a Webpack master just to create and ship optimal code. Now, keep that process running here. You can always quit it with Control-C, but then you will not have that development server anymore. Just like before, it's a server which will automatically reload whenever you change something in code, and you can view it on this page here, localhost 3000. So this is what I got here. Now, if we have a look at this, it's of course the same as before. It looks the same, but we got totally different code in there. We can find our code in the source folder. The public folder holds the one and only HTML file we got. And if we have a look at that HTML file, you see it's pretty empty, and it's also only one. Before, we had two. The reason for that is that with React here, and you typically do the same with Angular and Vue, we created a so-called single page application, which means we only have one single HTML page, and now JavaScript will render everything we see on the screen here and will change everything on the screen if it needs to. Now, before we used HTML for that, and doing it all with JavaScript would be a lot of work if we had to write all these instructions on our own. With React or similar frameworks, it's a breeze because React does the heavy lifting. Now, how does React know what to render though? Well, we got this root div here in our one and only index.html file. And if we have a look at the index.js file, which I can tell you is the first code that is being executed by our React application in the end, we see a bunch of imports and we see that in the end, we got some very strange code here, which we haven't seen before, and that we then target this root element in the index.html file here. So what is going on here? React and React DOM, the things we import here are features from the React library and the React DOM library, which of course is connected to the React library. React DOM gives us access to the DOM and allows us to render a so-called React component to that DOM in this place. Now, this here is a React component, and this here also is using this JSX syntax I mentioned earlier. It was invented by the React team, and this is definitely not JavaScript that would run in the browser. This is really important to keep in mind. Instead, this is converted to a real JavaScript instruction that the browser can execute before the code is shipped. So during the build process, so to say. So when you previously ran the Webpack command, now when we got this built-in development workflow, when that executes, this is converted. And actually, this is converted to React create element app. This is what happens here. This is the exact same. In the end, this JSX code is converted to a React create element instruction to which we pass a React component, which in this case here is a component coming from the app.js file. And we'll have a look into this file in a second. Now, because that's a lot to write, especially if we have more and more such components we compose together, we got this special JSX syntax, which does this conversion to this other code behind the scenes. This is also the reason why we're importing React here, even though I'm currently not using React itself anywhere in this file. Well, it implicitly gets used because this here gets converted to React create element, and then React is getting used. So this is this JSX code, and again, I do of course explain all of that in more detail in my React course. For now, we can just take for granted that with this instruction, we're rendering something in this place here, and that something is this app component, as I called it. Now let's have a look into this app file to understand what such a component is. If we have a look into the app.js file, we see, okay, here I got a function which is exported with a default export. I'm importing more things from other files. I'm importing React again because we see this JSX code again. And I'm importing something from the React Router DOM package. Another package not directly managed by the React team, but part of the React ecosystem, which in the end allows us to render different content for different URLs we're visiting. So that if I go to /myplace, the content of this page is swapped entirely and something totally different is rendered. With this here, we in the end tell React which component to render for which path in our URL. And this is then all happening in the browser, and it's using JavaScript there to then fill the page with content. So to tweak the DOM on the fly when we enter a different URL, for example. This is what React does, and the React Router helps us with rendering different content for different paths in the URL. So let's have a look at share place then, maybe. That's rendered for /nothing, so that's rendered when we just visit localhost 3000 /nothing. So if we go to pages, share place.js, we see a long file. Now let's have a look at it. In the end, what we got in there is an arrow function stored in a constant. So we got a function in the end. And that function in the end down there at the very bottom is exported. So I'm exporting a function in that file. And that's important. In React, you can write special functions, which in the end are normal JavaScript functions, but which behave in a certain way. For example, they always return JSX code. That's a must-have. Which are then treated by React as so-called React components, which is really just an internal term. It's nothing JavaScript specific. It's just a description. Now, such a function is a normal JavaScript function, but we're not calling it I'm in the end just passing this in create element here to React, as you saw before. And React then executes these functions for us to pass in data this function needs and to use this returned JSX code, which in the end is just a bunch of nested React create element calls, as you saw, to then, in turn, use all these instructions to render something onto the screen. And if you inspect this, you see we got a populated DOM here. So the DOM really was touched and content was added to the DOM. But all that was done by JavaScript. Of course, not JavaScript we wrote on our own. We're not having a single create element or append element line anywhere in this file or anywhere in this project. Instead, React does this based on our instructions here. That's why we have this JSX code, which the React team invented. It's simply more readable. It looks like HTML, even though it technically isn't HTML. So in the share place.js file, we got such a function which we export. We're importing some stuff from React and we're importing some things from other files. We're also importing a CSS file here, which is super weird. This is not React specific though. This is something Webpack can do if you add the right loader. In the end, that will just tell Webpack to also take a look at that CSS file and bundle it up and load it as part of your project into your HTML file as well, so to say. So this is something Webpack does here. Now let's have a look into our component function here though. It's a function which in this case gets no arguments. React would actually pass in some arguments here if we were interested, but here I'm not. I'll come back to which arguments we could get later. And then here I get a bunch of strange instructions using a useState function and a useRef function. These are functions provided by React, and this is the most modern React syntax we can use at this time to inform React about certain dependencies we have in this share place component, if you want to call it like that. React actually also has another syntax for creating components where you use the class keyword to create a normal JavaScript class, and that is also totally fine to use. You'll see that in many projects too. And in my course, I teach both syntaxes. Here I focus on this function-driven syntax though, which is perfectly fine to use and which is also the more modern of the two syntaxes. So here in this function, we then have a couple of function calls to useState and useRef, which are functions that are coming from the React library. In the end, these set up certain things for React to watch. For example, useState sets up certain state data pieces, you could say, which, when they change, trigger this component to be re-rendered on the screen. So whenever some data here changes, React goes ahead and updates the UI. And this reactivity is built into React. useRef gives us access to DOM elements so that we can read a value from an input, for example. Now, and without going into too many details, in the end, the way we build a UI with React is such that we have these states or these state data pieces. We use array destructuring here to get two pieces of data out of the result of useState. One is the current state stored by React, and one is a function that allows us to change that state, which then in turn will trigger such a UI update. And React will then have a look at our JSX code down there, and wherever we use some state that changed now, it will go ahead, reach out to the real DOM, and update that part of the DOM to match this updated state. As an example, we got that get current location button here, right? Now you see I added a click listener here with another new instruction, which we haven't used before. This again is understood by React. And here I'm saying if this is clicked, execute the get user location handler function. Now we find this function here as a nested function in this component function. Here it is. And that's the same function we built before when we built this whole project with just JavaScript in the end. Well, at least the rough idea is the same. However, here, for example, instead of creating a modal class and calling modal.show, which I did before, I'm setting isLoading to true with help of setIsLoading, which I get out of this useState call up there. Now this changes the loading state to true. Initially it's undefined because I didn't pass a value to useState here, which would be used to initialize this state. So initially it's undefined. Here I'm then setting it to true. Now then we get the user location, and once I got the location, I set is loading to false, and the coordinates and the address I got is also stored in state. And by calling all these set functions, the state is changed in React, and I tell React, hey, your state changes, you want to check your UI, your JSX code, if I'm using that state anywhere down there, and if I am, and if that now leads to a different output than before, please go ahead and update it in the DOM. That's what I'm telling React here. So when I get the user location, I save the coordinates, I save the address, I change the loading state. So what do all these changes do? Let's have a look at our JSX code. For example, I'm using the isLoading state here. These curly braces, that's some special React syntax, which mixed with the JSX code just tells React, hey, this is not JSX here, at least not entirely. Instead, this is all the regular JavaScript code mixed with some JSX maybe. So here, I'm basically having isLoading, and then I'm using this shortcut you learned about earlier in the course, where I say, if isLoading is true, then this should be rendered. So this is now my way of expressing that I want to render the modal if we're loading. And if isLoading switches back to false, then this will overall yield false, and this will no longer be rendered or returned as a result of this expression. And therefore, React will then go ahead and update the DOM and remove the modal content, which in the end is rendered. Because you see here, we also got some normal HTML elements in there, which in the end are output on the screen by React. So this is what I meant. You don't have these manual calls to create an element, to append it, to remove it. Instead, you define the result you want to have, possibly under a certain condition, and React will just make sure that this ends up on the page correctly, and that if I click get current location, we get this modal. This is something React will take care about. And it's the same not just for isLoading, but also for the coordinates which I got. When I got chosen coords, I in the end passed them here to my selected place component. This is also one of my React components, and unlike the other components we saw thus far, this component takes two inputs. You can think of these almost like function parameters which are passed in, and you'll see how these are received and handled in just a second. Same here for the shareable link. I bind the value property in the end of the input to shareable link, and I can change the shareable link, and I do change it with set shareable link in this page here or in this component. And when this changes and gets a new value, React will go to the places where I use shareable link, so for example here, and will update the value there on the screen as well. This is how React thinks, and that's of course just a quick summary. Definitely a lot to digest if you never worked with it, but it hopefully gives you an idea of how React works and what the huge difference to vanilla JavaScript is. You define the result, not the way how you reach it. And again, in my React course, you learn all about that step by step from the ground up, also with that alternative syntax, which I mentioned before. Now let's have a look at the selected place component, which we find in the UI folder. There we see we got some inputs, and therefore here I got this props parameter. If you set up certain inputs on a component you use, just like you would add attributes to a normal HTML element, React will bundle them all up as properties in one object which this component function receives. So in this case, the selected place component receives this props object, which holds the centered chords and fallback text properties, which I'm pulling out of that object with object destructuring here. Well, and then again, I use effect here, which is coming from React, which in the end just tells React that I can set up a listener to some data. And when that changes, I want to execute some code. So if I don't just want to update the UI reactively as before, but I want to do something else, upon data changes, I can use effect. I specify center chords as a dependency. That's what's being done with that second parameter I pass to use effect, which is an array of dependencies. And then inside of that function, which I pass as a first parameter to use effect, I can execute some code when that data changes. And here I'm then using the good old Google Maps package to render a map on the screen. That's what's happening in this component as an example. Down there, I also have a condition that if I don't have any chords yet, I show my fallback text. And that's it for React for now. I could dive in way deeper, but as I said, this is no React course, and it shouldn't become one. You can definitely learn React in way greater detail with my course, with my standalone React course. And if that way of building applications is interesting to you, you definitely should. The huge advantage is that you can focus on the what and on your business logic and not on the how. You don't need to do that detailed access to change something in the DOM. You don't need to manually take care that you got all the code set up correctly for interacting with the DOM. Instead, you define the end result and your different pieces of state and data that are used there, and then it's React's job to update this DOM correctly. And the same logic is used in the Angular and Vue, by the way. They have a different syntax, they have some additional features, and a totally different way of implementing this, you could say. But the general idea of having this declarative approach where you define the result you want to have and not the way to get there is the same. So definitely check out these frameworks for bigger JavaScript projects where a large chunk of your UI, or maybe all of it, should be managed with JavaScript. Such frameworks really take a lot of work off you and give you way more time and power to focus on what matters to your users instead of focusing on these nitty-gritty details. This will be an interesting module. It's about meta programming, or to be precise, it's about symbols, iterators and generators, the Reflect API, and the Proxy API. And these are all very niche and advanced JavaScript features, which you will, to be honest, not use that often. I would say they are most interesting to library authors. So if you're building a JavaScript package which you plan on sharing with other people, either by sharing it on NPM or even if it's just a company internal package, then some of these features might come in handy because all these features basically have in common that you can make life easier for other developers. So these are JavaScript features, but they're not like adding a click listener to a button, which does something which your end users will in the end have something from, right? Because they can click on a button and something happens. No, these are features which in the end allow you to change the way certain parts of the code behave or work, and they allow you to improve code safety, not from a security standpoint, but from an API standpoint, where you can, for example, make sure that the objects or the functions you expose to other developers are used properly. These are basically the things these features help you with. So we'll have a look at them in this module so that you heard about them, that you get the general idea, but you will probably not use them every day in all your projects. Still, if you encounter them, or if you are building some third-party library, or you're working in a very advanced project, then these features might come in handy. So what are these different features about? Well, let's start with symbols, though we'll later also have a look at iterators, generators, Reflect, and the Proxy API. But what are symbols? Symbols, and that's really interesting and good to know, are a primitive value. I did mention that before in the course. We learned about strings, numbers, booleans there. Now, symbols are also just yet another primitive value. Symbols are not objects, not reference values, they are primitive values. You can use symbols as object property identifiers, as keys in objects, so to say, just like you can use numbers and strings there. There are built-in symbols, and you can also build your own symbols, and we'll see both in this module. And that's the unique feature, or the special feature about symbols. They guarantee uniqueness. Every symbol you build is unique. So you can use symbols to add a key, to add a property to an object where you know that this name won't exist there yet. Because if you just created the symbol, it will be unique and you can't override an existing symbol of the same name there because every symbol is standalone and unique, and that's the biggest feature of symbols. Now let's see how we use them and what this uniqueness actually means. For this, I get a very simple project, which you find attached, just an empty HTML file where we import app.js, which is also empty, and then I just opened this here, because we'll not build a fancy user interface here. As I mentioned, all these features are less about end user interaction. They're more about code quality and writing code that you could share with others, which can have certain features that ensure that other people work with your code correctly. And as I said, let's start with symbols. Let's create a new symbol. Let's maybe name it UID for user ID, but you can name it however you want. And then you create a symbol by calling symbol. Important, not new symbol, that would not work, but just symbol, like a function basically. So symbol then creates a new symbol. If we now console log UID, let's see what we got there. If we save that and we reload this page, we see, we got a symbol there, right? And it's not too exciting, but that's in the end a symbol here. Now you can pass an identifier to symbol like UID, which is only for logging purposes, for identification purposes for you as a developer. Now if I reload here, you see that's part of the symbol and we can identify this symbol by that ID. This does not mean that this symbol now has an internal name, UID, or anything like that. This is really just an identification criterion for you as a developer. Now, how can we use such a symbol? Well, let's say we have a person object and we want to have an ID in there, ABC or P1 or whatever it is. Whoops, I should add an equal sign here. And we also want to have a name in there, Max, and an age 30. Now, this is a object, how we created it multiple times throughout the course. And here I got an ID property, which is just a regular property. It's not a symbol, it's just a regular key name. Now, here we'll have to do some mental yoga. Let's imagine you're building a library where you expose certain objects with the users of your library, just like the Axios library, which we used earlier, exposes the Axios object, if you remember. Now, in the objects you expose, you might have certain keys, certain properties, which you want to ensure are not overwritten by the users of your library. So let's say we had some library, maybe some authentication library, which creates user objects. And in the user objects, you want to give the users of your library, the developers using your library, the full power to change the objects your library spits out. But you want to ensure that all the user objects your library generates always have some ID identifier which can't be overwritten. Now, if your library would generate objects like this, then of course, let's say this is coming from a library. If I'm the consumer of such a library, I could always change the ID here like that. This is one scenario where symbols could come in handy. Let's say this here is library land. And this here is app land using the library. So we're authoring this library and then someone else is using it here with this code. So this is exposed by our library, someone else is using it, and we want to make sure that this should not be possible. Now, that's where we could use a symbol. Instead of adding an ID like this, if you want to ensure that only we, so only the code in our library knows how to interact with that ID, well, then we could just add this symbol as a key. And we don't do this by repeating the symbol name. This would just add a regular key named UID. Instead, we use this dynamic property syntax you learned about in this course, where you use square brackets here, and then you could point at some variable which holds the key name you want to use. Well, in this case, I point at this UID constant and will therefore use this symbol as an identifier here now. And then we could have P1 here. Now, this is a valid object, but the thing is, if we then use this object in our code, so we, the developer using the library, use that object, and we add or try to overwrite the ID with this code, we can do that, but we won't interfere with this library internal ID here. So if I console log my user object here, you'll see that the symbol is untouched by this line here. So if I now reload here, you see there we still got this symbol identifier. And since we know the symbol in the library, but this code is hidden away from the users of our library, users got no way of accessing this property here because they don't know this symbol. And if you would try to access something like symbol UID here, so I create a new symbol on the fly and try to access this symbol on the user object, you'll see that I get undefined for that. Because even though I use the same identifier here for the symbol, as I mentioned, this is really just for debugging purposes. This technically still is a new symbol, totally unrelated to this symbol. They're totally different objects. You can also see this if you console log symbol UID and check if that is equal to symbol UID, and you'll see you get false as a response here as output because these are not equal if I reload here. So that's the idea behind symbols. We do have unique identifiers which can't be accidentally overwritten, and only if we use that exact same symbol again. So instead of the library, if I then access this symbol again, I could change it. So here I'm of course using the exact same symbol I created here, and therefore not a copy of it or something like that, but really the same symbol, and hence I can change it. But if I don't expose this symbol as part of my library, users of the library have no way of using it. So now with that, if I save that and I also console log user here and save that now, you'll see that now I changed that symbol user ID to p3, but I did that inside of the library. It's not available outside of it. Now, of course, you're not limited to using symbols inside of libraries. This is just a common example or a use case where it might be particularly useful. Also be aware that you don't need to add such an identifier. This here also is a perfectly fine symbol. You don't have to add the identifier, you just can add one so that you as a developer, if you console log that or if you use the debugging tools in the browser, that you can identify a symbol and you remember where in your code you set this up. You technically don't have to add that. Now, besides the symbols we can create, and you can create as many as you want, there also are so-called well-known symbols. These are symbols that are built into modern JavaScript, basically JavaScript after ES5, so ES6 or higher, and or they were built in before too, but now you can access them, I should say. And these are symbols that can help you do certain things. Now we'll see the symbol iterator thing in action a little bit later, for example. This allows you to actually make any object iterable with the for off loop, which by default is not possible for a regular object, for example. It is possible for an array though, but I'll come back to that. Now we got other well-known symbols there in the end. These are just symbols that are built into JavaScript, which you can access on this symbol object if you don't execute it like a function, but instead as a object with a static property with the dot notation. Then these are symbols which were created by JavaScript, so to say, and which you can therefore use, and which JavaScript then in turn also tries to find for certain actions, just as we as a library author can try to use the UID symbol here to, for example, reassign the value or extract the value. The JavaScript engine also has certain built-in symbols which it also uses in certain circumstances. For example, when the for off loop gets executed, it tries to find that symbol iterator symbol here, the built-in iterator symbol, on an object and see if the for off loop can be used on that object, because it requires that and some logic attached to it to use that. But we'll see that when we dive into iterators and generators. For now, just be aware that there are a bunch of built-in symbols. Most of the time you will not really need them, though there is one, for example, which I want to show you, and that's the toStringTag symbol. We have an object here, we have the user object here. Now, when we console log user, you of course see this works quite well here, and in the Chrome browser, we print this object. Now, technically, if we would call toString here on the user and we console log the result of that, you, however, get this object thing here. Now, that simply happens because the toString method called on any object just prints this. The toString method exists because it exists on the default prototype every object has, but of course the output here is not too useful. The fact that we can look into the object with console log is a little convenience offered by the Chrome browser in the end. It's not something we can rely on. Normally, it should actually just print the result of toString, because that's what console log typically does. But for objects, the browser gives us this extra utility of actually printing the object in an analyzable way. So toString is something we can call, though, to convert the object to a string which we can show to a user, for example. Now, as I mentioned, what we then get is this here. Now, you can add a special symbol here to the user object, again with this dynamic property assignment syntax. And here I want to use one of the built-in symbols. So we access symbol here. So this symbol object, we execute it as a function up there. And then dot toString tag. Now, toString tag allows us to define a tag as a value, so a string tag here, which will then be part of the output that is generated here. For example, here we could say user object. And now if we save that and we reload, we see now we're printing object, user object. Of course, therefore, we could also just print user here. So this allows us to, for example, tweak what the toString method outputs here. Of course, we could also simply overwrite the entire toString method if we want to customize it completely. But if we just want to change that tag, which is part of the default output, we can do that with this built-in symbol. Now, whilst this is not something you will use every day, because we could argue how useful and important that is, it shows you what the idea behind these well-known built-in symbols is. They are used by some JavaScript code, some default JavaScript code, in this case here by the toString method which exists on every object. And JavaScript looks up these symbols. And if it then finds them, which it does here when we define it in our own object, it uses them. So that's what we can do here. And this would not work if we would try to create our own symbol toString tag. Because as I mentioned, this is just an identifier for you as a human. This is totally ignored by JavaScript. This does not create a symbol of the same kind we just used. This creates a brand new symbol which JavaScript simply doesn't look for. So we have to use this symbol, which is built in, which JavaScript is aware of and which JavaScript looks for because it uses this all the time internally. So that's the idea behind symbols. You can create unique identifiers for your objects, which you have to know in order to use them. So that were symbols. Now let's move on to iterators and generators. And let's start with iterators. An iterator is simply an object in the end, which has a next method, which then in turn returns a result of a certain structure. For that, let's say we have another constant, company, and that holds an object where we have employees. And there I got Max, and I got Manu, and I got Anna in there. Now this is a regular object. We make it iterable, or we turn it into an iterator, you could say, by adding a next method here, which we can add like this. Now, the name has to be exactly next. Now, in this next method here, we then should return an object where we have a value property. This could be employees, this employees 0, so the first element in the employees array, and a done property, which simply signals with a Boolean whether we got more values we can output or not. Well, then we should probably also have another property here, current employee, which initially is 0, which we use to track which employee we already output. So that here we can access this current employee and store that in a return value variable or constant. I'm not going to change this. And thereafter, we can set this current employee to current employee plus 1 by incrementing it, and then we return our value here. To be precise, we also want to check if we still have employees left through which we can loop by checking if this current employee is greater or equal than this employee's length. We know if this is the case, then we're out of employees because we then have no more employees left. So here we could return a value of this current employee to return the number for which we failed and set done to true to signal that we are done looping through that. Now, what's the idea behind this next method though? Well, now we can console log company next and execute this a couple of times down there. If we save that and we reload, you see we print all different employees until we're done. So what we do here in the end is we create our own method that allows us to loop through a specific field of this object. And we could have any looping logic we want in here. So this in the end kind of makes this a loopable object. Right now we can't use it with for-off, but we soon will be able to do so. But we have an object where we have the method, which we can call multiple times to go through any logic of our choice. In this case, to go through all employees, but of course it's totally up to you through which field or whatever you want to loop through here. So we have a method which we can call multiple times, and every time it will return something different. And not just that, it will actually go through some list of data. It will exhaust some list of data. And when we exhausted that list, we'll not get an error. We'll simply get a response. We'll get back a value where we see that we're done. Because of this uniform return value, where we always have a done property, which is true or false, we also know if we can call next again and have more values left, or if that's not the case. Now, this alone, as I said, might not be totally helpful yet, but this already is a logic you could use in some applications where you have an object which you use as a data storage, and you want to go through some custom logic there to output some data which is stored in there. You don't want to use a for in loop, because you're maybe not interested in all the properties of this object, but just in some of the values in one specific property of this object. And then such a custom looping logic could be quite interesting here. Because what you could, of course, do with that is you could create a while loop and have a result here, or let's say an employee. And for that, you call company next. Then you have a while loop. And as long as employee is not done, you continue looping. And then you can console log employee value here, or do whatever you want to do with it in the while loop. And thereafter set employee equal to company next again. And now we have a dynamic loop, not a for-off loop, but still a loop, which will in the end go through all employees with our own iterator logic. So if we save that and we reload, it outputs the 3 employees we have, and then it stops, because then done is true, and therefore this exit condition kicks in, or this running condition is no longer true, and therefore we make it out of that loop. So this would be one example how you can use your own iterator company, which has this next method, which then in turn allows you to have your own looping logic for whichever field or whichever logic related to this company object you might have. So that's an iterator. Now, iterators are nice, and with a while loop, you can create your own looping logic. But maybe you would want to do for const employee of company here. Maybe this is what you want to do. And at the moment, this would not be possible. If I console log employee here, and I save that, you'll see I get an error. Company is not iterable. Now we get this next method, but JavaScript is actually not looking for a next method when you use a for-off loop. Instead, what it is looking for is a special symbol. It's looking for a symbol, which I can add here in company, of type symbol.iterator. Another well-known symbol built into JavaScript, obviously, otherwise for-off couldn't be looking for it. And now what is the value for that symbol? That's the interesting question. The value has to be an iterator. Now remember, company overall is an iterator because any object with a next method is an iterator. So what we store for this symbol iterator property now should be such an object with the next method. So not company should have the next method. Oh, well, it can, but that doesn't help us. But what we store in the symbol iterator property should be an object with the next method so that we can use for-off. And now instead of creating such an object manually again, we can use something else which builds us such a iterator. And that would be a generator. A generator is something in JavaScript which builds us an iterator object. So which builds us an object that does have a next method built in. A generator in the end is a special type of JavaScript function which automatically generates iterators for you. So which generates objects that have a next method, you could say. That's a generator. You create such a generator by using the function keyword, and then, and that's special, you add a star after this keyword. This turns this function into a generator. Then you can use any name you want here, or of course also write an anonymous function. Here I will assign a name, employee generator. And then you have a normal function signature. You can get parameters here, and you have your function body. But the star is really important here. Now, inside of this generator function, you can now write your looping logic. So here, we could take our while loop here, copy it and comment it out down there, and move it into our generator function. So now here, I'm looping through all my employees using my own next method. So I'm still using this. We still have that. But now, instead of console logging the employee here, what I do is I use another keyword which is available in JavaScript, and that's the yield keyword, and I yield the employee value I got here. Now what does this all do? Well, this here in the end generates a new object. This function, when it's called, generates a new object which has a next method on its own. The fact that I use another next method in there does not matter. We can do that, but we could alternatively also put all that logic in here and just wrap it into a while loop to go through all employees here. And indeed, just to avoid confusion, let's do that. Instead of utilizing another iterator function we wrote, let's write a new loop here where we got the current employee, let's say, where we start at 0, and that should be a variable, of course, so that we can change it. And then while current employee is smaller than this employee's length, we want to continue with that loop. And inside of that loop, I then yield this employees for the current employee. So now here we got a loop that should also go through all employees, but we get this special yield keyword. The yield keyword is a bit like return. It basically returns the thing after the yield keyword as a value, as a result of this function call. We use yield though because this is not a normal function. We have this star here turning this into a generator. Now what yield does is it kind of pauses execution. Well, not really, because what the generator function overall does is it isn't executed like this. Instead, when this generator function gets executed, an iterator object will be created. So an object which has a next method. This generator function builds you such an object. It gives you basically what we wrote before manually out of the box. And the yield keyword will then basically define the return value of every call to the next method in that generated object. Now, sounds complex. We'll see it in action in a second, of course. And it executes until it encounters yield, and then it returns the value after yield and pauses at the point where you had called yield. And when you then execute the same function again, it does not start from scratch again, but continues running at the point where it paused before. And I can show this to you here. Let's comment out this for off loop, and let's instead, for now, not use a symbol here, but use any key here. Get employee. Any name of your choice. So now here, if I console log company get employee, and I call this as a regular function, and then call next on that function, because this here, this generator, produces in the end an iterator, so it produces an object with a next method for us. That's what a generator does. So the return value of get employee is not what yield returns, but it's just such a iterator. It's an object with a next method. So I have to call next on the result, which we get back here. And with that, if we save that and we reload, we see we get exactly the same as before, but now we're not calling our custom next method up there. This is not happening. I could comment this out and comment out this current employee property here to make it really clear that this is not getting called, and it will still work because the generator built such an object for us with its own next method. And we can call this next method multiple times, of course, as you see, and this will then execute our logic here. Now, as you see, it always, however, yields me max here. The reason for that is that whenever I call getEmployee, I generate a new iterator. So instead, what we should do is we should create a new constant here and call company getEmployee once, and then use that same object all the time down there. In addition, after changing this, we should also make sure that in our generator logic here, we also increment current employee by 1. With these changes here, we now change that whenever we yielded a new value, we increment that value. And therefore now, if we save that and we reload, you see I print max manu Anna, and thereafter undefined, and we are done, which we aren't before. Now this is our own generator logic doing its work here. Now, why is that useful now? Well, for one, we have a very simple way of creating an iterator. We don't have to write our own next method as we did before. We just have this short logic here. And yield is the special thing here together with the star. This allows JavaScript to build such an iterator behind the scenes. And whenever yield is encountered, this basically is the point where JavaScript saves the current state of execution, and the next time you call the next method on the created iterator, it will continue from that point on, and therefore then give you the next value and the next value and the next value wrapped into such an object where the actual value you yielded can be found on a value key, and you get this additional done property that tells you whether there are more values left or not. Now, and if we combine this with our symbol here, so if we don't use getEmployee here, but symbol.iterator, well, then we can actually tap into some native JavaScript features to loop for our object here. Now we can indeed comment out this code down there and use such a for off loop here, and it should work. If we do this and we reload, you see I'm printing max, manu, and Anna here. Because what a for off loop does is it goes to this object you're looping through, and it searches for this symbol iterator thing there. Then it executes the function which it finds there, which should be a generator. So that in the end, this returns an iterator, right? If you execute that generator function, you get an iterator, as you learned. And then JavaScript executes the next method on this iterator it got for you, as long as done is not true, and extracts the thing in the value property into this constant here, which you can then use and consume inside of your for off loop body. And this is how you can write your own for off loopable objects with the help of this special well-known iterator symbol and this generator function. Now, of course, iterators and generators, these are very advanced features, but this really can be handy if you want to write your own looping logic. You can either do it manually by adding your own next method and making sure it gets called correctly, or by simply writing such a generator function, which together with the yield keyword allows you to define when the function should pause or when a new value should be emitted the next time the function is called again and again until there are no more values left. So until there are no more yield calls found in the function execution, which in this case happens once we make it out of this while loop. And then together with this special symbol, you can use for off. You can also use the spread operator now on this object, for example. If I console log company here, this normally would not work, not like this at least. But here, you see it works, and it gives me these 3 employees because the spread operator also behind the scenes looks for this iterator symbol. It then goes through all the values we get there and adds them as elements here in this new array. These are symbols, iterators, and generators, an advanced feature which still can come in handy in certain scenarios. So iterators and generators can be a confusing concept. In the end, just keep in mind that a generator function, the function with that star here and with the yield keyword, is a function that returns a new object which has a next method. So what we wrote before manually. Now you can write it manually, and you could also just store an object with the next method here as a value for the symbol iterator, and you would be able to use for off. But using a generator function is simply easier. It's less code. What you yield here in the end will be the return value of the next method later. And the generator function will create an object with such a next method, where the next method will automatically return an object with a value property with whatever you yielded here, or undefined if you're not yielding anything new anymore, and a done property, which is either true if it is done or false if there are more values that can be extracted. And it's this exact concept, this iterator symbol with such an iterator object, that is used under the hood by arrays. If we add a new array here, persons, where we have max and manu, then in the end you'll learn that such an array is just an object, right? An array is just a special type of object, you could say. And if we console log this persons array and we save that and reload, we see this array like this, but we also see, for example, that it has a length property, because it is an object which basically has properties with an identifier of 0 and 1, but also a length property. Now, if we check the prototype of the array object, you will actually find this iterator symbol if you watch closely. This is something an array has on its prototype. It has all these array methods you learned about, filter, find, and so on, but it also has this special iterator symbol. And the function here is then just a generator which yields us such an iterator object, an object with the next method. So an array, this default array we worked with all the time internally, just uses the same logic we set up here. And at least for that, even if you don't need to write this code on your own that often, this should be helpful for understanding how arrays work internally and how they are managed and how the data they return is managed. Because since an array also has a length property, we need some logic that controls that we only return these values on 0 and 1 here if we loop through this array. And the logic for returning just that lives in this generator function and in the iterator next method, which is generated when this generator function gets called. This is how arrays work internally, and this is how generators and iterators work in general. So with that, we can also utilize symbols, the built-in iterator symbol, to work with iterators and generators, which allow us to create our own loopable values, if we want to call it like this, and which basically now help us understand what arrays and strings do internally and what we can do our own on our own objects. With that, let's move on to the Reflect API. Now, what is the Reflect API all about? It is totally not related to iterators and generators and symbols. It is related to objects, though. It is an API that allows us to control objects, to do things with JavaScript objects. And in the end, it's just an object itself. Reflect is an object in JavaScript which groups with a bunch of static methods on this class, so to say, which groups a lot of functionalities that help us work with objects. It has standardized and grouped together methods, and the Reflect API, just like all these features, can be used to control how our code is used, how our code behaves, and so on. Now, let's see an example and let's see what the Reflect API offers us. For this here, in our dummy app.js file, I'll go down a bit further. And here I want to start working with the Reflect API. So let's say we have a new object here. To mix things up, I'll name this object not person and so on. I'll just name it course. Now, a course might have a title, JavaScript, the complete guide. Now, it's a very simple object, of course, and we work with objects so much, shouldn't need much explanation. Now we got this Reflect API, which we can access on this global Reflect object by adding a dot thereafter, because this has a bunch of static methods we can use. For example, it has a define property method. It has a delete property method. It has a get prototype of method, and it has a set prototype of method. For example, we can use set prototype of to set the prototype of our course object to an object where I have a toString method, my own toString method, where I return this dot title. And the consequence of that would be that if I now console log course toString here, We no longer use the default toString method, but my own one here, and hence if I save that and reload, I print the course title in this case. So the Reflect API helps us work with objects. With setPrototypeOf, we can set the prototype of an object. With define property, we could add a new property, and not just like this, but also with such an object descriptor, this extra argument you might remember, where we can set whether this is writable, so whether we can write to this property or if it's locked, and so on. I covered this earlier in a lecture where I talk about object descriptors. So in the end, the takeaway is that the Reflect API gives us a bunch of methods that help us change objects, work with objects on a meta level. Because what we do here is typically something we do to prepare our object to be consumed by some other part in our code. Again, consider that you are the author of a third-party library, and you expose certain objects as part of this library, and you want to make sure that certain properties can't be changed by the developers using your library. That could be one scenario. Well, then you can use the Reflect API to, for example, set a property and set it to be non-writable. The obvious question that just could arise at this point is, why would we use Reflect for this? If we use the global object with a capital O, we also have a setPrototypeOf method. We also have a define property method, and it generally works the same way as the Reflect API methods. So why do we have the Reflect API if we can already do these things with the existing Object API? The Reflect API is newer. It was added recently with ES6 to JavaScript. The Object API is way older. Now that alone, of course, is no reason for using it. Instead, the Reflect API has two advantages over the Object API. For one, there are subtle differences regarding the behavior of some methods. For example, if a method fails to do its job on the Object API, it might return undefined or fail silently. On the Reflect API, you might get a better error, or it just returns true or false for a given method to tell you if something worked or not. And attached you find a link with a comparison of the Object API and the Reflect API that allows you to understand these subtle differences. Additionally, the Reflect API bundles all features that you need to work with objects. For example, it also has a delete property method, which we don't find on the Object API. There, this is not a thing. If I try to call delete property here on course and pass in the title with the Object API, then you will see that if I print my course down there and I reload, this does not work, because Object delete property is not a function. The Object API has no delete property. Instead, previously in older JavaScript, if you wanted to delete a property in an object, you would have to use the delete keyword and then target the property you want to get rid of. Now, you can do that, but it's a bit of a strange code. Having this special operator here, I think it's a bit cleaner to have a method you can call on an object if you want to get rid of a property. Because on the other hand, we also do have a method for defining a property. So why not have one for deleting it? Well, that's, for example, one thing the Reflect API added. There you now have a proper delete property method, and that simply is cleaner than using this delete operator. Here you can pass the object where you want to delete a property, and then the property name, and then this will return true or false depending on whether this operation succeeded or not. So this is simply cleaner and more straightforward than using this delete operator. Technically, it's of course doing the same. But that's why we have the Reflect API. It's there to group all the methods you need to configure your objects, to work with your objects. And you don't have to fall back to different approaches, where some things are defined on object and other things are not defined there, and you suddenly need a special operator. Now the Reflect API gives you everything you need to work with objects, all bundled in this global Reflect object here. And that's basically the idea behind the Reflect API. Whenever you need to do such meta work on your objects, delete a property, define a new one, change the prototype after the object has been created, then you should consider using the Reflect API over the other scattered methods or operators you might be able to use for that. That's the primary reason for the existence of the Reflect API. And that leaves us with the Proxy API. Just like the other features here, it's basically a meta feature which allows us to tweak our objects or add some extra functionality to our code that kicks in when other people work with our code, which is why it's called meta programming. We configure our code to behave in a certain way when other people use it, which is this extra level of thinking we added here. Now, the Proxy API is all about creating so-called traps for certain object operations. You can almost take the word trap here literally. With the Proxy API, you can step in upon certain operations and execute your own code. For example, if someone wants to retrieve a property, so the value for a property of an object, with the Proxy API, you can set up some logic that runs in that case, which allows you to either change what is returned or do some additional task. Again, for this meta level where you might want to track property access or make sure the objects your library exposes are used properly. So again, it's an API that allows you to control how your code is used and which impact it has. Now let's see it in action. To see the Proxy API in action, I'll comment out this delete property line here, and instead now start working on this course object with the Proxy API. So let's see what the Proxy API can do for us there. When I say the Proxy API, I mean that there is a special object in JavaScript called proxy, which you can actually instantiate. This creates a new proxy object, if you want to call it like this. Let's store this in a constant, which I'll name pCourse for proxy course, because I will apply this proxy to this course object so that we have this special course object thereafter. Now, this proxy constructor function takes the object on which this proxy should be applied. So here I will pass in the course object. I will point at the course object. Now, the name proxy, you might know that from networking. You can use a proxy server to disguise your IP address, for example, to basically reach out to the web by funneling your traffic over another server, which then is actually the server talking to the websites and so on. Now, here it's kind of similar. You wrap an extra object around your existing object. We wrap an extra object around the course object. Now, that alone wouldn't be that useful. Instead, this proxy constructor actually needs two arguments. The first argument is the object which you want to proxy, so which you want to wrap. The second argument is another object which defines certain handlers for the wrapped object, so certain behaviors for certain operations you might want to perform on the wrapped object where you can then step in. For that, I'll create a new object here and store it in a constant named course handler. And in this object, you got certain handler functionalities, certain traps, as they are called, which you can define. For example, a get trap. Now, the names you can use here are clearly defined, and attached you find a link to the MDN documentation on the Proxy API, where you find all available traps and all available operations you can listen to and step in. Here with get, I define a handler, a function in the end, here with this method syntax, which is executed whenever someone tries to read a value from the wrapped object. So whenever someone tries to access a property, tries to get a value from a property of the wrapped object. The get method then takes two arguments, which are passed in automatically by the Proxy API. The object on which this get access happens, which is our wrapped object then, and the property name on which this happened. Now for now, I will just console log property name here, and then return object square bracket property name, which means for the wrapped object, I access this property name, which you tried to access, and I return the value which is stored in there, which means I forward this value retrieval request without blocking it, without changing it. I just retrieve the value which someone tried to get for this object and give it to that someone. Now this course handler object is then the second argument I pass to my proxy, and with that we got the readily configured proxy object. Now let's see what happens if I try to access pcourse.title. This title property does exist on this object because the proxy object, which is actually stored in pcourse, wraps itself around this, well, wrapped object and basically assumes all of the properties and methods of this wrapped object, just funneling all access through the traps you define here in the handler. So now if we save that and we reload, I do print my title here, but you also see this output here, which is coming from line 98, where I print title. This is coming from my handler here, where I log the property name, and this shows that this code indeed is executed. Whenever I try to access a property, this code executes and tells me which property I try to access, the title property, and if I'm interested, for which object I try to do that. And then here I actually define what, for this get trap, is returned. Here I'm just getting the user who tried to get this property the actual value, but we could return anything here, like the something string. If I do that and I try to console log the title, you see instead of logging JavaScript to complete type, I log something, because I override what I fetch here with the help of the proxy API. Please note that neither course nor pcourse were changed by that proxy. If I save that and reload, you see I return something here, but we got the title still set to JavaScript to complete type, both in our original object, but also in the proxy which wraps this object, as you can see. So the title was not changed. I only have this trap which steps in whenever you try to get any value of any property, which then allows you to do stuff. So here I'm hard overriding what we return. A more useful behavior could be that I, for example, check if object property name is a thing, and if it is, I return that, or with this shortcut you learned about at the beginning of this course, I return not found. By doing that, I make sure that accessing the title should work, but for example, if I try to access a length property, which does not exist, instead of getting the default value of undefined, I now get not found. So if I reload here, we get the title, but then not found instead of undefined. So this might be a more useful scenario where we could use the proxy API. Now all of a sudden we're not using it to block access or return some dummy value, but instead we're using it to improve the usage of our object. Again, keep in mind we're talking about meta programming here. If you're writing a library which you're exposing to other users, then these users might use your exposed object incorrectly. Maybe a developer writing some code based on your library tries to access a property which doesn't exist in the object your library returns. Well, by default, this would give the developer undefined. Maybe for your library, you don't want to return undefined, but return some other default value, like not found, or a number, or another object, or whatever it is, and then you can just do that. Of course, you could also take into account which property the user tried to access. If property name was length here, for example, you could return something else and just have this default fallback for any property not named length. So for length, we could return a number of 0 and only return not found for any other property which didn't exist, like rating, for example. And now with that, if I save that, you see I get the title, then 0 for the length, and then not found for the rating. So that's what you can do with the proxy API and the get trap. Now we don't just have the get trap, though. The get trap is a very useful trap, but you also got other traps for other operations people might perform on objects. And again, attached to the last lecture, you find a link to MDN where you find all available traps. Now, one other trap that can often be useful is the set trap. The set trap allows you to step in when users try to set a value for a given property. So here again, we could register a method, or we would have to write this as a method, and we get the object for which this was tried, so the wrapped object in the end, the property name users try to set, and the new value users try to assign to that property. And then you could use this to validate all incoming values, to lock down access entirely by not doing anything in here, or you simply forward that and you do indeed set the property name on the object to the new value. This would be a set trap, which basically does the same thing you would do by default. Now if I try to set the rating here, for example, to 5, this would just work. If I save that and I reload, you see I print 5 here for my rating, because I just forward this set request. On the other hand, I could check that, for example, if people try to set the rating, so if the property that the user tries to set here is rating, I just return and I don't do anything. And I only proceed and do set the value for other property names. So now, for example, when I try to set rating to 5 here, you will see that when I print it down there, it is actually not found because it was not set, because in my set trap, I actually block access and I return so that this line does not execute if the property name which users tried to set was rating. So you can use this to block access, to do any other logic. You could also send data to your own analytics server, sending data to register any settings to any properties in your objects. You're totally free to execute whatever you want in these traps. Now also be aware of the difference to getters and setters. You learned about getters and setters earlier. Getters and setters were always focused on one specific property. You added a getter with a certain name and a setter with a certain name. These traps, however, are flexible. They're not bound to a specific property name. They kick in whenever you set a value to any property or whenever you try to get the value of any property. So they're way more generic and flexible, and you, as a programmer, therefore have full control over how you want to allow access to properties of the object you might be exposing to your colleagues, to yourself, or to consumers of your library. Now, this is as deep as I want to dive into this. As I mentioned, all these features you learned about in this module are pretty niche. Symbols, iterators, generators, the Reflect API and the Proxy API all have their use cases, but the use cases are pretty advanced and often found in scenarios where you are writing code which is not directly impacting end users of an application, so people visiting a website, but instead other developers that might depend on your code. Because you are authoring a third-party library, because you are working in a team, or you're writing your own reusable code, which you maybe want to reuse in different projects you're working on. Then these features can help you control how the code can be used, how it behaves, how certain things are locked down or controlled behind the scenes. You can make your objects loopable with the iterator symbol and generators and iterators. And with symbols in general, you also have a feature that allows you to have properties in objects which are not that easy to access and which most importantly are not that easy to change because you need the exact same symbol to access it. So with these meta features, with these advanced features, you are now really fully prepared to become an expert JavaScript developer and dive into all the depths of the language. And whenever you encounter these features anywhere, you know what they're doing and how you can work with them.